Hello everyone, this is a video about how to calculate logs with logs. So remember, logs deal with exponents. That's the whole point that you would ever use a logarithm, is because you're trying to calculate an exponent. And exponents are related to square roots. Square rooting is kind of the opposite of exponenting. Neither of those are truly verbs, but we're going to pretend like they are. Okay, and you can calculate logs with logs by applying the rules of exponents and square roots. So here is a typical type problem you would get here. They would say, pretend that you are stranded on a desert island, and you are trying to calculate some logarithms. But the only logarithm that you can remember is that the log of 9 is more or less 0.95. So you have no other calculator with you. This is all that you have, and this is the only log that you remember. So can you, using this information, can you calculate other logs? And the answer is, of course, yes. For instance, I could tell you the log of 81. That is because the log of 81 is the same thing as the log of 9 squared. See how I put it in terms of 9, because 9 is the only one that I know. And then the log of 9 squared is the same thing, using the birdie rule, as 2 log 9, right? Because this 2 flies over and lands in front of the log. Well, 2 log 9 is 2 times the log of 9, which is 0.95. And if I do that math, it might take me a little while without a calculator, but I would eventually get to 1.9. So I know that the log of 81 is 1.9. Likewise, I could calculate the log of 729. How? Well, if I remembered that 9 cubed is 729, I would be in great shape, wouldn't I? Then I would use the birdie rule to get 3 log 9. That means 3 times the log of 9. So that's going to equal 3 times 0.95, which I might have to write in the sand to figure it out, but it's 2.85. I could also figure out the log of 3. How would I do that? Well, I would say that the log of 3 is the same thing as the log of the square root of 9, because the square root of 9 is 3. And the log of root 9 is the same thing as the log of 9 raised to the 1/2, right? Because a fractional exponent means a square root sign. And then I do the birdie rule, and so I get 1/2 times log 9, which is 1/2 times 0.95, which will give me 0.48, more or less. Okay, so you see that using just this one bit of logarithmic knowledge, I was able to calculate these other logs. Now, why would you really want to do this? You wouldn't, right? Because let's face it, none of us are going to remember what log 9 is tonight after dinner, much less if we ever, get stuck on a deserted island somewhere. We're just not going to know that. We're going to have a calculator with us. So why are we doing all of this? Well, we're doing this because this kind of helps you see how logarithms are related to each other. It's kind of a cool math thing that you can do, and so we want to practice doing it. Now you might say to yourself, I don't really need to know how to do this because I will have my handy dandy calculator with me when I am taking my tests, and if I want to know the log of 81, I'm not going to go through all this rigmarole. I'm just going to type in, what's the log of 81? You are wise, but also foolish. Because what the questions will do is they will give you a rounded off number here, this 0.95, and so you're going to get imprecise answers over here because you rounded. And if you use your fancy dancy calculator, you will not be rounding to the same place, and so it will not work out perfectly, and the answer that you want to select will not be there. So you need to learn how to do this. Before we go, let's do one more round of examples. Let's say that you are stuck on a deserted island, and the only log that you remember is you remember that the log of 16 is roughly 1.2. Okay, so why you remember that, I don't know, but you did. So let's calculate the log of 4. How would we do that? Well, how do we go from 16 to 4? And remember, we're only allowed to use exponents and square root signs. So to go from 16 to 4 using an exponent or a square root sign, I would say the log of the square root of 16, because the square root of 16 gives me 4. So that is the log of 16 raised to the 1/2, because that's what our principal square root sign means raised to the 1/2. And then I can use my birdie rule to do 1/2 log 16, or 1/2 times 1.2, so I get 0.6. So I was just able to calculate the log of 4 with only knowing the log of 16. I could also do the log of 2. Really, you say? Yes, really. I could do it just by taking the square root of this. Since I just figured this out as 0.6, I could use that. But I'm going to start with 16 because that's more fun. So the log of 2 is the same thing as, stay with me now, I know it's going to be crazy, the 4th root of 16, right? Because 2 times 2 times 2 times 2 gives us 16. You're thinking to yourself, I would never figure that out if you did not tell me, Mrs. DeLisi. And to which I say, well, if you are on a deserted island, you have lots of time to think about math stuff. So you probably would be able to figure it out. Okay, so the 4th root of 16 is the same thing as 16 raised to the 1/4. And then, again, using our birdie rule, that is 1/4 times log 16, or 1/4 times 1.2. You could think of that as 1.2 divided by 4. However you choose to think of it, 0.3 is the final answer that you get. Let's do just one more. Let's do the log of 1/16. You're saying, oh, I'm just going to stick a 1 on top of this. No, 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 no. You have to go through all the rigmarole. So the log of 1/16 is the same thing as the log of 16 to the -1. Do you see how important it is to remember all these exponent rules? It's just like essential at this point. So log of 16 to the -1, we are again going to do our birdie. So we have a -1 times log 16. And that is going to equal -1 times 1.2, because that's what the log of 16 is, which is going to give us -1.2. And that is the final answer. So basically, this is just a big exercise in manipulating stuff using square roots and exponents. But that is how you find one log when all you know is another log.